So now we want to talk about factoring trinomials. In other words, polynomials that have three terms. Now before we do that, let's just kind of review again and practice a little bit more with FOIL. So here, if I'm asked you to find the product, I'm going to be foiling. So I'm going to take the product of the first. That gives me k squared. Product of the outers plus 4k. Product of the inners, 3k. And then product of the last. 3 times 4 is 12. And then I would just combine like terms. 4k plus 3k is 7k. So we get k squared plus 7k plus 12. Let's look at this next one. So again, I'm going to be doing the same thing. I'm going to take the product of the first, r times r, gives me r squared. Then I'm going to do my outers. So minus 5r. Then I'm going to do my inners. That's another minus 5r. And then I'm going to do my last, positive 25. And when we combine like terms, we'll get r squared minus 10r plus 25. So let's look at number 3. So again, just doing this real quickly. We're taking the product the first, then outers, then inners, and then last. Again, the other way to think about it, you're distributing the r to each term here and then distributing the 2 to each term here. So that'd be r squared minus 5r minus 14. And let's just do one more for good measure. So that gives me b squared minus 7b plus 8b minus 56. Combine like terms, that gives us b squared plus b minus 56. Now, factoring, we're going backwards. We want to be able to start with something like this and get into this form. And a couple things you want to notice. If I'm starting with this, notice this negative 56. That came from the product of these numbers here. So this gives me the possible, when I'm looking at this number here, it's going to give me the possible factors I have here. Also notice that these numbers here add up to 1. That gives me the coefficient here. So what I'm going to do is, if I have to go from scratch from here to here, I'm going to first list the factors of negative 56 until I find a pair that add up to the coefficient of the middle term. So if this is factoring trinomial form of x squared plus bx plus c, where the coefficient of the squared term is 1, factor out the greatest common factor, list all pairs of factors of c, determine which pairs m and n found in part 1 you can add to get b. If you get the opposite sign for b for the sum, then change the signs of m and n. If the pair of factors cannot be found, then the trinomial is said to be prime. Rewrite the trinomial as x plus m or an x plus n. If the original trinomial was in the form of x squared plus bxy plus cy squared, then the result would be x plus my plus x plus ny. And then you can FOIL to verify that the product gives you the original trinomial. So here's what we're going to do. I'm going to look at this last term, 36. And I'm going to start going through the factors, different ways I can get 36. I can do 1 times 36, 2 times 12, 2 times 18, my bad, 3 times 12, 4 times 9, and then 6 times 6. Well, that first pair is 37. That adds up to 20, 15, 13, 6. 6 plus 6 is 12. So this is the one that I want because 6 plus 6 is 12. So this is the pair I want. That tells me I can rewrite this as n plus 6 times n plus 6, or we can rewrite that as n plus 6 quantity squared. Let's try this next one. So here I've got -7. So since that 7's negative, that means my product's negative. That means one factor has to be negative and one has to be positive. My only choice here for 7 is 1 times 7. I have to make one of them negative. So I'm going to look over here. I want that to be a -6. So I need to make the larger number negative. And sure enough, if I take 1 plus a -7, that does give me -6. So now I can factor, bring down my x's, do a +1 and -7. And keep in mind, I can double check my answer. I can go and I can FOIL this out like we did up here. And if I FOIL it out, I will get what I originally started with. All right, so let's try this next one. So my last term is -12. That means my factor is going to have opposite signs. Since my b is positive, I want the larger number to be positive. So when I do -1 times 12, I want the one to be negative. But that adds up to 11. That's not what I want. So let's do a -2 times 6. That gives us 4. So that doesn't work. Let's do -3 times 4. Well, that's the combination I want. So I'm going to have x minus 3 times x plus 4. And that will be my factorization. If you're having trouble generating these numbers, in other words, if you don't really know your multiplication tables very well, I can show you a quick little hack. So if you got your T30XS, and if you hit the table key, let me clear that out, it's going to have you put in something. So here's what we're going to do. I'm trying to figure out what these numbers are. So I'm going to take whatever number this product here, I'm going to write this -12. Oops. And make sure when you're doing that, you're using this negative down here. And I want to divide that by x. Well, this is my variable key. And then I'm going to do plus x. So I'm trying to find a sum of 1. That's my goal. So I'm going to take negative 12 divided by x plus x. Now, if then I hit enter, and here I always want to try starting my table at 1. Do it by steps. Just hit OK. Just keep hitting entering. And so when one of my factors is 1, that gives me negative 11. When another factor is 2, that gives me negative 4. 3 is negative 1. Well, I don't want that. I want 4. That's a positive one. That tells me one of the factors is 4. If I then take negative 12 divided by 4, I can get the other factor. So that's a little hack you can do. So let's take a look at this one, and we'll do it both ways. So here I got a negative 27, and so this 9's positive, so I want the larger factor to be positive. So I'm going to do negative 1 times 27. That gives me negative 26. Negative 3 times 9. That gives me 6. Okay, we're kind of in trouble here because this would give me negative 1 plus 27 is negative 26. This one would give me a negative 3 plus 9, which is negative 6. I don't get, oh sorry, positive, excuse me. That should have been a positive, 26. Neither one of those add up to 9. So what this tells me that this cannot be factored. And when we say it's not factorable, we say the word prime. If I try doing that hack on my calculator, see if I can get out of that glare. So let me go back to, let me quit out of this. Let's go ahead and hit table. And this time I'm breaking down 27, negative 27. Enter. Go start at 1. And you can see here I get my negative 26 and negative 6. There's no way I can get a positive 9. I mean, I'm just doomed. I can keep going. I can get positive 6. I can keep on going forever. I'm never going to find a sum that adds up to positive 9. So that's how you do it on your calculator.